Did you know that no two people see the exact same rainbow? It's true. A rainbow isn't an object but an illusion. We see it when light plays tricks with our eyes. Imagine sunlight showering down like a hose. Now picture those tiny drops of water in the air like a million tiny prisms. Light zips through these drops, bends and bounces back to us. But here's the cool part. The light doesn't stay white. When light bends inside a water droplet, it splits. This phenomenon is known as refraction. As light enters the droplet, it slows down and changes direction. This bending causes the light to spread out into its constituent colors. It separates into all the colors that make up white light. This process is similar to what happens when light passes through a prism. The prism acts like a water droplet, breaking the light into a spectrum of colors. Red, orange, yellow, green, blue, indigo, and violet. The whole gang's there. These colors are always present in white light, but we only see them when the light is dispersed. This splitting is called dispersion, and it's the secret ingredient to our rainbow recipe. Dispersion occurs because different colors of light bend by different amounts when they pass through a medium like water or glass. You don't always need rain for a rainbow. See a spray of water from a hose on a sunny day, rainbow. The tiny droplets of water act like countless little prisms, creating a mini rainbow right in your backyard. What about mist near a waterfall? Rainbow time. The mist from the waterfall scatters the sunlight, producing a beautiful spectrum of colors. Anytime light and water droplets combine in just the right way, a rainbow can appear. Whether it's after a rainstorm, near a waterfall, or even from a garden hose, the magic of light and water creates these stunning natural displays. Each color of light bends at a slightly different angle. This phenomenon is known as dispersion, and it occurs because different colors of light travel at different speeds when they pass through a medium like glass or water. When white light enters a prism, it slows down and bends, but each color bends by a different amount. This separation of colors is what creates the beautiful spectrum we see. Red light bends the least, which is why it appears on the outer edge of the spectrum, while violet bends the most, ending up on the inner edge. This difference in bending angles is due to the varying wavelengths of the colors. This difference in bending is why we see the colors spread out in an arc, forming a rainbow. When sunlight passes through raindrops in the atmosphere, it acts like a prism, bending and separating the light into its constituent colors, with red on top and violet on the bottom. The order of colors in a rainbow is always the same: red, orange, yellow, green, blue, indigo, and violet. Think of it like a race. Each color starts together in the sunlight, but as they pass through the raindrop, they take different paths based on their wavelengths. All the colors start together in the sunlight, traveling as a single beam of white light. But when they enter a raindrop, they take different paths, bending at different angles due to their unique wavelengths, spreading out and showing their individual colors. That's our rainbow. This natural display is a perfect example of how light interacts with the world around us, creating beauty from simple physical principles. People have been mesmerized by rainbows forever. But it was Sir Isaac Newton back in the 1600s who cracked the code. Using a prism just like our raindrops, he demonstrated how white light is actually a mixture of all the colors of the rainbow. Newton's discovery revolutionized our understanding of light and color. He showed us that the rainbow wasn't just a pretty picture, it was a scientific phenomenon with measurable, predictable properties. So, next time you're lucky enough to spot a rainbow, take a moment to appreciate the science behind its beauty. Rainbows are not just a visual treat, they are a fascinating interplay of light and water droplets. When sunlight passes through raindrops, it bends or refracts and then reflects off the inside surface of the droplet. This process splits the light into its constituent colors, creating the vibrant arc we see in the sky. Remember the sunlight, the raindrops, and the amazing way light bends to create a spectrum of color. Each color emerges at a different angle, which is why we see a sequence of colors from red on the outer edge to violet on the inner edge. This phenomenon is not just limited to rainbows. You can observe similar effects with prisms and even in the mist created by waterfalls. It's a reminder that even the most magical things in nature have a scientific explanation. Scientists have studied these phenomena for centuries, and their discoveries have deepened our understanding of the natural world. The study of light and optics has led to numerous technological advancements, from cameras to fiber optics. The most amazing fact: you'll never reach the end of a rainbow. This is because a rainbow is an optical illusion that depends on the observer's position relative to the light source and water droplets. As you move, the angle changes, and so does the position of the rainbow. It's an optical illusion, its position changing with your perspective. This shifting nature of rainbows has inspired countless myths and legends, but the reality is even more fascinating. The science behind it reveals the intricate dance of light and water, a dance that is both predictable and endlessly captivating. So keep chasing those rainbows, keep asking questions, and never stop exploring the wonders of science. Each rainbow you see is a reminder of the beauty and complexity of the natural world, a world that is always ready to reveal its secrets to those who are curious enough to look.